Good morning, friends. In the last lecture, we'll talk about the SN1 reaction mechanism. In detail, we have seen about the SN1 reaction mechanism. That is nothing but a unimolecular nucleophilic substitution reaction. Today, we have to see in detail about the SN2 reaction mechanism. That SN2 will stand for the bimolecular nucleophilic substitution reaction. It proceeds in only one step. It generally in this reaction simultaneous bond breaking and the bond formation will be there. Nucleophiles attacks the substrate carbon simultaneously. That nucleophile will attack on the substrate carbon. Simultaneously, the bond between this particular leaving group will break and that leaving group will leave that place. Here the example is taken Rx plus OH minus as a nucleophile gives you the ROH plus X minus. Mechanism will be like that, only one step will be there, Rx plus OH minus. At that time OH will attack from the back side and there will be the simultaneously bond formation and bond breaking will be there, that ROH plus X minus will form. This SN2 reaction is a second order reaction because the rate of the reaction depends upon both the concentration of the substrate and the concentration of the nucleophile. You got this point? What happens in that? See here. Simultaneously bond making and the bond breaking will take place. First of all the bond will break and then the bond will make. Means bond breaking and the bond formation, these two processes occurs simultaneously and it is only one step reaction. In the one step itself it gives you the formation of this particular ROH. Mechanism is shown by, this is the transition state. This is the intermediate or transition state which is highly unstable, which will give the formation of alcohol along with the removal of the leaving group. Then this particular reaction is second order. Why it is a second order? Because this reaction depends upon both the concentration of the substrate and the concentration of the nucleophile. Therefore the rate expression is written as rate is equal to K in bracket Rx, concentration of Rx into concentration of this particular nucleophile Nu. Double dot is there, Nu minus, or you can take the OH minus also, no problem. The reaction between the methyl chloride or the methyl iodide with the base, or say base is nothing but a hydroxide ion. Hydrolysis of this particular methyl iodide, you can take CH3I plus OH minus will gives you the formation of this particular transition state, then this particular methyl alcohol plus I minus. Energy profile diagram is shown, only one peak will be there because only one step is involved, only one that hump will be there, that is the transition state. You know this reaction energy gap between this particular reactant and this transition state is nothing but energy of activation, and the energy difference between the reactant and the product is nothing but a delta H that I already explained you. Only one energy count you will get in this particular reaction. Then the stereochemistry of the SN2 reaction. Most of the SN2 reaction proceeds with inversion of configuration of the substance. Nucleophile or say incoming group attacks on the substrate from the opposite side to the leaving group. Such attack will help, or such attack will flip the other groups from one side of the carbon atom to the other side of other side. This process is known as the Walden inversion, and it produces a product of opposite configuration. You can take any example. You can say X is going from this side, then that particular thing. Inversion will be there. Inversion of the configuration will be there. Okay. That example you have to remember. You can take any example here. In general, it shows that particular thing is there. Okay. 2-bromo-octane, optically active, reacts with the NaOH under the conditions where the assembly mechanism followed. It gives a product with the inversion of configuration. You can write this example also, no problem. Any example you can check. This is the 2-bromo-octane. 2-bromo-octane is there. C6H 13 CCH3, here H is there, Br 2-brom. The second position bromine is there. This OH minus will attack. You have to show this diagram. Okay, this is the one more example to you. It is in general. Only one example you have to write, either general or write. You can specifically you can write in the example. It's very good. Got this point? What is there? Very simple. It is SN2 stands for the bipolar nucleophilic substitution reaction. Okay, which proceeds in only one step. Okay. It deals with the simultaneously bond breaking and the bond formation. Nucleophile attacks the substrate carbon simultaneous. As pushing out a leaving group in a concentrated faster. Simultaneous as it pushing out a leaving group in a concentrated as it push out the leaving group, that you can write. Okay, then this is example you have to write R plus OH minus will Rx plus OH minus will give you the ROH plus X minus. Then you have to show the mechanism how this proceeds. Simultaneously bond breaking and the bond formation will be there. That's why OH will attack from the back side. OH minus dot 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 R dot 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 X, which will give the ROH plus X minus. Kinetics of this reaction will nothing but it depends upon the rate of this reaction. It is a second order reaction because the rate of the reaction depends upon both the concentration of the substrate and the concentration of the nucleophile. That's why rate is equal to K in bracket Rx into concentration of the nucleophile, that you have to remember. Okay, then next energy profile diagram. You have to draw example. You can take this example or back example. About the stereochemistry, you have to write it gives you the inversion of configuration. Okay, and such a process is called as the Walden inversion, that you have to remember. Either you draw this example or say that whatever the example we have seen, this example 2-bromo-octane, which is optically active, reacts with the NH under the condition where the SN2 mechanism followed. It gives the product with inversion of configuration, that you have to write the example. You can write this example also. Okay, no problem at all. Please practice it well. It is a very simple mechanism. Okay, don't you have to practice it well. When you practice it well, then no issue at all. You can write the answer. SN1, SN2, you have to prepare simultaneously. Out of this three mechanism, one mechanism will be there in the exam. today we will stop here. Please go through this lecture. Thank you.